My name is Louis Fev. I worked with Hallie, Gabe, Tatsuya, and Tim to work on the Cas13 imaging project. This is a project about trying to visualize what we see in Cas13 editing, which can be done via gel, but we can also now do it via live imaging of the Cas13 itself. For this project, my research question is this. I'm going to read it. It's Cas13 has been shown to make an adenosine to inosine edit by using the Western blot gels, and can we show the same results using a single molecule imaging on high resolution light microscopy? Essentially, we can see something on the gels, and we're wondering if we can see it in more resolution using our microscope. This microscope is built by Tatsuya, and it is worked on by our lab. We have some physicists in our lab, as well as biochemists and some of people who are both. And so this is what our research is based off of. And for this, I came to the conclusion that indeed we are able to visualize the Cas13 edit much easier. I'll read this, what it says. So my thesis is that we can visualize. It is essentially considering that CRISPRs are visualized with Marin Toda Philosophia Aragotute gRNA complexes, MP-Argo RNPs. Light microscopes and images collected from them cause us to believe that Cas13 can indeed be shown through avenues of real-time visualization via high-resolution light microscopy. Essentially, we think the answer is yes. Okay, so starting broad here, we're going to start with what we have seen in the past using gel level resolution. One of our researchers, Hallie, went through and re-showed some of those images from the Cas13 paper on SDS page. And what that showed here was that Cas13 edits, and we were able to see that in the gels. I'll show you in the next slides what that looks like, but essentially that was a band showing up a little darker versus a little lighter. And so it is true that the band was not entirely absent, meaning that there was some read-through of the X codon in spite of there being an X, but I'll get into more of that later. So here we see the Western protein gel shown in Cas1388R. So on the left, we will see a Western blot with no edit, and on the right, we'll see a Western blot with an edit. And the Western blot with no edit shows a lighter band, and the Western blot with an edit shows a darker band. So here is the half of the Western blot with the light band. We're seeing that at 1 kb, and here we have the half of the Western blot gel that has the edit, and it shows the darker bands. On the bottom, if you look at the labeling, you see you have the ladder, and then you have the 20 microliter of the different types of the cell. So what we saw here was we saw no edit, and that was a band that was a little lighter, and then we saw a band that was yes of an edit, and that was a little darker. So diving into that no edit form, we had our Cas13 HPF HF PHF03 and 04, and one of them is, and those are just two variations of the Cas13 strain which we had, and we were able to show those a little. We were able to show both that in the guide version, in the non-guide version, that those were not present because they were not edited, and I'll explain what guide is in a future slide. So similarly, the edited version is here This shows a darker band, and it shows that we had to see a little bit more Cas13. Well, this one is showing ADAR, and we show that the ADAR is present when we have our edit. And the ADAR is showing up darker, meaning that we have more amount present. And so that was that picture of that half of the western blot, and we were able to put the two halves together in the western blot, which was able to just show that they were both showing the same thing, and that was great. So now getting more specific into what exactly that looks like, I'm going to explain to you what that reporter, the editor, and the fluorophore are, what that means, how they look like in the cell and in theory.